Hello, myself Vivek Ayre, and today in this video I'll be discussing about non-parametric test, and that test is Krushkal wallis test. It is also known as a HTest. The video session flow will be the first will be discussing about this test. Second will be practically seeing how the test can be run in SPSS software, and will be later interpret the result of that test. Usually the tests are divided in two parts, the parametric test and non-parametric test. The parametric test run when your data sets are in a normally distributed, and we are running the non-parametric test when your data sets are not normally distributed, and we'll be discussing about this Krushkal wallis test H test, and it is from the non-parametric test model. So the introduction. So first, this Krushkal wallis test introduced by the Krushkal and Wallis in the year of 1952. It is a non-parametric approach to the one-way ANOVA. That is why it is also known as a one-way ANOVA rank. And ANOVA is from the parametric test model. And usually when we are running this Krushkal wallis test, the normality assumptions are not required. So without checking the normality, we can run this test. The first point of use is the test is more commonly used when you have three or more levels in your data, like as in independent variable, like when your independent variable having more than two category. At that time we can use this test. Even for the second point, for two levels considered using the Mann-Whitney test, but it is an extension of Mann-Whitney test. Usually if our independent variable is having only two levels of data, we can go with the Mann-Whitney test. So it is an extension version of this Mann-Whitney test. Another point, dependent variable. When your dependent variables are in a ordinal scale, ratio scale, or interval scale, at that time we are also using this, and we can compare the mean rank of two or more variable by using this test. Let's take an example of this test. If a researcher wants to know the investor's attribute for investment in mutual fund, the investor living in rural, semi-urban and urban area. Okay, the investor attribute and the investor living in rural, semi-urban and urban area. Here the rate of attributes are rate in a scale of 1 to 5, and that is the 1 for the strongly agree and 5 for a strongly disagree. This is what the scale 1 to 5 is given. Here the questions are like asked in this manner. The first, area of residence, so the people from the different area, rural, urban and semi-urban. And here the same attributes are asked in this way. The attributes is the investor is investing in a mutual fund, actively investing in a mutual fund. So here 1 to 5 scales are there. For 1 is for strongly agree and 5 for the strongly disagree. Okay. So what will be the hypothesis for this? So the null hypothesis for this test and for this example will be there is no significant difference in the attribute for investment in a mutual fund for investor living in a rural, semi-urban and urban area. The alternative will be there is a significant difference in a investor attribute for investment in mutual fund, investor living in a rural, semi-urban and urban area. So let us discuss this hypothesis. Let us understand this hypothesis by practically running this test on SPSS software. So here the same thing I have in the numeric way, that the respondent here I have collected total number of 150 respondent, and the first column indicate the area of resident. Second is investment in a mutual fund. If you will be click on a variable view, you will be identify which values are assigned here. Okay, so same, first will be assigning the value 1 for rural, add second for semi urban add, and third that is for only urban, and we have added, and okay. So and the same way we have given the value for this: 1 for the strongly agree, 2 for agree, 3 for neutral, 4 for disagree, and 5 for strongly disagree. And if you will be see the measurement for the first, for the area our measurement is nominal, and for the scale for the second investor attribute we have selected the scale as a measure. So what you have to do by performing the test: first you have to go to the analysis or analyze, then after select non-parametric test, where you will be finding the several non-parametric tests, but for the Kruskal-Wallis test we will be select k independent sample. Again, first you have to click to the analyze, go to the non-parametric test, and here the k independent sample, click on this. So you will be finding this tables. Okay, what you have to do first, the you have to add your variable, like my dependent variable is I actively invest in a mutual fund, so I'll be put here as a test variable list, and the independent variable, the area of resident, I am selecting as a group variable. Now here in this group variable you have to given the range, like our residents having a 3 level, so our minimum is 1 and maximum is 3. Here will be right 3, and continue. So as per your data, if your data sets is having a level 4, so you can give a minimum 1 and maximum 4, so it will be vary from the available data set. Now I'll be select on an option and will be click on descriptive. Okay, so and continue. So by default you will be finding that this step test type, that is a Kruskal-Wallis HTest, is by default selected, so you don't need to select again. Okay, and then click OK. So here the result will come up. For the first table is indicating that a descriptive statistic. The second one is for Kruskal-Wallis, where you will be finding that the mean rank is 74, 74 and 79 for the urban. Almost in a point there is a digit value. And the significant value of Kruskal-Wallis test is 0.854. So we can say that it is more than the critical value of 5%. So we fail to reject null hypothesis. So our conclusion will be, so from the test we can interpret that the significant value of Kruskal-Wallis test is 0.854, which is more than the critical level of 5%. So we can say that we are failed to reject null hypothesis, means we have selected the null hypothesis, and the null hypothesis is saying that there is no significant difference in attributes for investment in a mutual fund investors living in a rural, semi-urban and urban area. Even in one of the way we can say that there is almost the mean rank of are similar in the different residents and their areas. So this is what the overall practical implication of this test and result discussion. So thank you.